Alright, we're back. We are back. It has been a while. Certainly has been a while. Atelier Rorona. The usual. In addition, upon special request, today's lecture. Upon special request, yeah. Today's lecture is going to be on Unity's data-oriented technology stack and what it looks like relative to the standard object-oriented design principles that games are traditionally made out of. Unity side, of course. I only have the frame of reference of Unity. Said person, though, however, is presently tardy, so that will buy me a little bit of time to get my bearings back. I haven't touched this game in like over 2 weeks. So, the lecture will begin shortly, when eventually this butt decides to show up. I can talk as much crap about him as I want to because he's not here yet, and it's not like he watches the playback. Okay. Royal Festival. Yes, food. Foodstuffs. I think I'm almost done with the stamp card, yes. I'm very almost done with the stamp card. If I remember, I spent last time... What did we do last time? Oh, that's right, I went to the new area. Where like they had like the bunny-eared Kuni. There was something else there. Lots of big birds. And yeah, I guess that's where we were meant to get a lot of the new foodstuffs at. So let's try to do that. The less I have to focus on the game, the easier it will be to lecture. So yeah, for those in the future, it's probably easiest to find the lecture when it starts at the first point a person appears in the chat. He will probably show up in the chat. Which, if it does take him too long, I'm just going to start without him. But you know, we do have to make it look like we're playing the game properly. Oh, I got a buzz. Oh, okay, he's about to come on. Fair enough. Looks like we're... Oh, here he is. Welcome. Currently, at the moment, I am playing the game properly. Couldn't sleep while not breathing, so I'm here. You know, that would be kind of a challenge, wouldn't it? Like, try holding your breath and falling asleep, I guess, is moral of the story there. Which you have a whole suite of issues that you are currently dealing with. So yeah, like I said, I'm just getting myself settled into the game first before I get into the lecture. I guess before I do that, if you have any questions anything that you think I absolutely have to mention, then do tell me now. Otherwise, I'm just going to ramble. Flower. Where's my flower? Damn, when is it gonna start programming in dots in Unity 6 and start making her own Tears of the Kingdom using the Havoc engine? She's She's been doing this for a while. I don't know why you're so surprised now. This is all old news by this point. Also, where the heck is my flower? Am I just blind? But yes, she is going to become the master at programming in Unity Dots. Of course, we are limited by the fact that I will have no visual aids. Well, okay, I'll have like one visual aid, but apart from that, it's like, yeah, really no visual aids. I could have sworn I had the recipe for flour though. Hold on, that's bothering me. Where is it? Because everything I'm trying to do right now kind of becomes so much harder if I don't have flour. So true. Wrong thing. I have to remember what all these buttons even do. Welcome viewers to the lecture on Unity Dots. I know it looks like we're playing a game, and it is indeed we are playing a game. It's just what we do. So yeah, so again, if any questions of what you want me to cover before I start from literal ground zero. Nope, no questions. Alright. I guess we're starting from the basics. Alright, basics. What is a video game? Yes, what is video game? So anybody who has had any amount of experience dealing with game design, especially with Unity. Again, Unity is our frame of reference here, because I physically do not have a frame of reference for any other engine. So Unity has what it calls the mono behavior. It is a class that is defined to kind of serve as the basis for how you actually interact with the objects within your game space. So you would have a mono behavior. You would write a class that inherits from mono behavior, for example, like a building. And by inheriting from mono behavior, you are allowed to now attach it to objects in your actual development space. So in your 3D world or 2D world if you're just a psychopath. But yeah. So the mono behavior is kind of the basis of everything, and it's what gives you the game object, which lets you actually interact with the object itself, lets you access its position within the space, all that good stuff. So when you consider, I'm going through a lot of context here. When you consider what it means to program with object-oriented design, one thing that is kind of always going to be true is that it's not friendly to performance at all. My object-oriented design professor, he goes out of his way to mention in one of our previous lectures how by using the object-oriented design paradigm, your system will run about 20 to 30% slower compared to one that is designed using just general functional decomposition. So that brings us into kind of why dots. Because obviously we know games. Games are, well, sometimes if the game runs slow, we don't like the game. Which I think you were the one who put the quote. Yeah, it was you who was like, not necessarily related, but what was it? It was like, delayed games are bad, Rush games are bad. Bad games are bad. Games are bad. Don't make games. So I guess the preface to all of this is don't make games. That is #1 life lesson. Do not make game. Okay, so games are bad, don't make games. Indeed. Shigeru Miyamoto. Indeed. The legend. So again, performance. There have been like studies, quote unquote, of Zelda. Wait, oh yeah, that's right. Some of these IPs are so old you kind of forget who made them. Yeah, but when we consider, made me lose my train of thought. Oh well, it's fine. Dots. Indeed, performance. Yes, performance. That's what I was at. Again, so object-oriented design, 20 to 30% slower, which the main benefit we get from object-oriented design, if the viewers have seen any of my other lectures on the exact same topic. Hold on, we have a cutscene.
失礼する。依頼の進捗を確認に来たが。いらっしゃい、ステルクさん。ああ、ハトだ。本当に連れてきてくれたんですね。約束したからな。それで依頼の話なんだが。クルッポー。クルッポーって言った。やっぱり可愛いな。私も飼いたいな。ハトのことは後でもいいだろう。まずは。あ、そうだ。ハトってクッキー食べますか？昨日作ったのがあるんですけど。ああ、こいつは甘いものが好きだから。それじゃ持ってきます。待っててね、ハトさん。クルッポー。とても話ができる状態ではないな。お前を連れてきたのは失敗だったか。
We always enjoy these. Alright. So what is Unity Dots? I guess is probably a good first question. And in reality, it's kind of a lot of things. It's the data-oriented technology stack that I believe is pre-6, has been out for a couple of years now, and I think Unity 6 has full support for all of its features. But the Dots includes ECS, which is going to be the main topic for today, netcode for entities, which ties into ECS, the burst compiler, and I also like to include jobs. Technically, you can do jobs without ECS. It's just it's significantly harder because you have to be thread safe. Which, I guess I'll review those ones first. Unity jobs is basically its method of multi-threading. Obviously, when you think of multi-threading, a lot of the issues come with concurrency control, which Unity decides it just kind of doesn't want to deal with. So it handles all of that in the background and imposes restrictions on you to make basically everybody's lives easier. But again, it also means that if you want to run objects through your jobs, well, you can't, because again, those aren't a lot of times those aren't thread safe. But that's just jobs. Today is not about jobs. Jobs are complicated. The burst compiler is a quick mention. It's basically whenever it compiles your code, it turns it into this thing called, like, I think it's like native code, which is much closer to the machine language, and thereby is significantly faster to actually run. So that's why when you see burst compiler, it's usually designed to exactly increase performance. Yeah, the netcode for entities is basically how you just make multiplayer using ECS. Which I would say is self-explanatory, but I guess it technically isn't. But yeah, ECS stands for Entities, Components, and Systems. It's kind of the way you're meant to kind of visualize the game and the world rather than as objects. Which again, objects are basically just encapsulations of functionality and data. Which is kind of, it's always kind of interesting when you hear it referred to as data-oriented design, since technically everything manipulates data, it's just the way in which that you deal with it. I got a voucher. But yeah. So, what is our benefit of ECS? Because I will tell you right now, I've already told you this before, but ECS is a pain in the butt to work with. Because it is inherently unintuitive. The way you kind of have to think about things. Oh, I don't have anything to turn in. Oh, does pie not count as food? Dang, okay. So, we're gonna have to address a lot of context, so to speak, in terms of how the computers work to actually get a good understanding of why dots is better. Because, obviously, all you really need to know is how to use it, but it would be nice if you can, you know why dots. So, I guess it starts out first with kind of how memory is organized. How the way we organize memory on the computer. So obviously, when we think of our computer systems and everything that they do, everything is in memory. Like physically, that is how data is stored. So from the browser window at the moment to the file on your desktop to literally the operating system that shows you all of these things. All of that's in memory, and one of the things that the ECS system attempts to manipulate is basically cache. So I already know you've taken this, but this is just for everybody else. I say everybody else as if there's more than you, but nonetheless. Memory is organized in kind of 3 different parts, so to speak. You have your cache, you have what we basically just refer to as main memory, and then we have the disk. And they're kind of ordered in terms of how slow they are to access and exactly how much capacity they have access to. So the cache is basically right on your board. The processor can access it in a ridiculously fast speed. But by the nature of it being close to the board, it means that there is very little of it. It is very expensive. Because obviously when you're working on the board, a lot of your board is dedicated to the actual connections between all of your devices to actually allow the system to run the machine. So cache, we can't have a whole lot of it. And the next one is main memory, which is a little bit slower. It is quite a bit slower, I guess, when you think about it. But there is a lot of it, and it's kind of where most of the stuff happens between cache and main memory. And again, I'm like simplifying all of these concepts very much so, because it's just easier that way. And then lastly you have the disk, which is very far away from everything, but it has the most space because of it. So you can literally just put it anywhere. This big fat, I don't know how to describe a disk. It's basically just a box, I guess, which a box with a cylinder thingy, but it's a minor detail. But yeah, so that's kind of how we organize our memory. And again, how I mentioned how speed was important when you're looking at all of these different forms of memory. So if you were to, if we imagine a scenario where you needed to access the cache, we'll just say for example it'll take you like 10 milliseconds. I think I've had a problem in operating systems that was like 10 seconds, so we'll go with 10 seconds. And we'll say that accessing main memory is, I don't know, like 30 milliseconds. Just for simplicity. And then the disk is really far away, so it'll take maybe 100 milliseconds to get over there. So just with this example, it's kind of easy to see how the kind of the major difference moving between the cache, main memory, and the disk is. So like your cache is like, you know, it's like somebody who's going up to the front door of your house and walking into your house, and just it's very nice and easy. You just walk into your house and you just look around, and if it's there, great. It was very fast. If it wasn't, well then you have to move to the next layer of this memory hierarchy, which you'll have to take a step outside, walk across your luxurious manor into your backyard, which is significantly larger than your house, for very obvious reasons. But from there, you have to look through this main memory space and figure out, okay, is what I'm looking for here? If it is, that's alright as well. If it's not, well then you have to go to the next layer. Yeah, which involves hopping the fence of your estate, and you know, walking half a mile down to the nearby forest, where there is a whole heck of a lot of space. But it takes you a little bit longer to get there. You know, we're talking roughly about, like, in this example, whatever the difference between 30 seconds and 100 seconds is. So, if you have to go all the way to your disk, all the way into the forest, that already takes you the 10 seconds to walk into the house, the 30 seconds to walk through your backyard, your luxurious mansion backyard, and then 100 milliseconds to get to the forest. So you find it in the forest, right? There's a little spinny thingy that when you're looking for something and it finds it for you, and you grab it and you're like, great. Well, now you have to walk back. You have to walk back to where you started so you can actually take what you found and process it. So you already had 140 milliseconds of travel to get to where your stuff was stored. And why you stored it in the forest? Well, it's because your house ran out of space. And so now we're talking a commitment of, what was the original number? 140? A commitment of 280 milliseconds to get the thing that you were looking for. Which doesn't sound like a lot, but it is quite a bit when you consider relative to the cache. You know, the process of 10 milliseconds to get to the cache and find what you're looking for versus the process of, you know, 280 millisecond journey to actually find the thingy that you're looking for. Okay, cutscene break. Where is this guy?
探してるんですか？
おお、君か。この辺りで王を見かけなかったか。
王？王って王様ですか？
その様子では知らないようだな。まったく王国祭の直前に逃げ出すなど。
逃げちゃったんですか？
ちっ、声が大きい。あまり公にしていい話ではないんだ。
ごめんなさい。王様って一番偉い人ですよね。なんで逃げちゃったんですか？
大方打ち合わせに飽きたとかくだらない理由だろう。
そんな理由で。
そういう方なんだな。とにかくもし見つけたら私に連絡するか、力ずくで捕らえるなりしてほしい。この際多少怪我を負わせても構わん。
それはさすがにまずいんじゃ。
それくらいの気概で臨まればあの方を捕らえるなど不可能だ。ではよろしく頼む。
大変そうだな、ステルクさん。あれ、そういえば王様ってどんな人なんだろう。私顔も知らないかも。
Yeah, it's kind of not a good start. So yes, memory. Which all of it's going to come together, I swear. But definitely, but the first component that will kind of make up our why for dots is memory, where again we have cache, main memory, and disk, each one getting significantly slower to access at each level. Then we get to the second point, which brings us to, well, objects themselves. How the computer represents our objects. So, say, for example, we have a car. I always start with car because that's the first thing I can think of. Well, when we're trying to represent this car in our game, and it comes with a whole lot of, different... Yeah, they come with a whole lot of different attributes. Again, the nature of objects is they are things that store attributes and functionality and encapsulate them to do a lot of things. That's for a previous lecture. So if we have, say, our car to exist within our 3D world, our nice 3D plane where we're going to be driving around loads of cars. Obviously our car is going to have a lot of data associated with it. Think, for example, the color of the car, license plate depending on how complicated your game is. And in addition, a car will have 4 wheels in most cases, unless we're talking about, like, freight train sized, trucks. Which, I guess if those are in your game, then we're talking like upwards of 18 wheels on your vehicles. All of those things are stored inside this thing we call an object, and a class that we snap the name car on. So that brings us into kind of the... Tied in with objects are data types. And data types will be very important when it comes to actually working in the entities component system architecture. Danish. Oh. Yes. So in computing we have what we call primitives. When we think of primitives, think integer numbers, our floating point numbers, our Boolean values, our true or falses. I feel like I'm missing one, I probably am. I'm trying to figure out what food to make at the same time. But yeah, those are our primitives. In most cases, when you are defining a primitive, the system looks to the memory and says, okay, I know how large this thing is. For example, an 8-bit integer will be, well, 8 bits long.
どれを使おう
So it will know this, and it will allocate that much memory somewhere within your memory, your system's memory. And whenever you define this integer,
どれを
it
使おう
just puts it there. Whatever value you give it, it puts it right there.
これでいいよねそれじゃあ調合するよで
So yeah, so direct memory allocation, it knows exactly how large it is. Then we get to things like objects, user-defined objects, or things like most strings, like strings in most languages. If we're talking specifically in Unity, the game object is very obviously an object. We also have the vector 3, which gives you the location of whatever it is you're looking for
これなら簡単簡単
in the world.
どれを使おう
So all these things are objects, and
どれ
when
を
the
使
system
おう
looks at them, it's like, I don't know how large this thing is. So it's going to store it
これ
as
でいいよ
a
ね
reference
それじゃあ調
variable,
合するよ
meaning
できた
when it allocates
ど
space,
の
it needs to
特性
allocate
を
a
つけよう
space
か
that it knows. So it allocates enough space for a memory address. A memory address where you can go and find everything you need from this object that you have on your own defined. So for the example of our car, that would be an object. So when it looks at a car, it'll say, okay, I don't know what this is. I'm going to create a reference to it, and whenever you assign data to it, I'm going to put it there.
何を作ろうかな
So that's exactly what it does. It puts it there. But we're talking our car that has, in and of itself, objects within its attributes. So for example, our tire. A wheel, is very much not a primitive data type. Nor is the vector 3 that tells you where in the world it is. So
よいしょ
when it puts this car there, it's like, okay, here's where I'm going to put your tires. Oh wait, I don't know what the heck a tire is. So I'm going to also put a reference for this tire and point it over there. I'm going to put it over there, whatever it is this tire is, I'm going to put it over there. And it does this for, well, every single tire, and the vector 3. So when you want to access this car object, for example, in your game, somebody decides to click on a car and look at the car. You know, your game is meant to show them what the car looks like.
ちょっと自信ないな
So
何を作ろうかな
So when it does that, it's like, okay, it says it's supposed to be here. So it runs over to that memory location where it knows the car is. And it's like, okay, I didn't find the car. I found the reference to where I can find the car. So it follows that reference, and it says, okay, here's the car. It has tires. Wait, what is a tire? I need to follow this reference now to figure out what the heck a tire is. And that's what it does.
簡単簡単
And it follows each of those references and finds the car.
どれを使おう
So, when you think about moving a car onto the show floor so somebody can see it and sit in it and do all these things, you can't show up with only half the car. So you
どれ
can't
を使おう
you can't wheel this car into the showroom
こ
with
れでいいよね
3 of its wheels missing, without the engine, without the paint coating on it, without the steering wheel, all these things that come with the car. Whenever you want to show off this
調合
car,
するよ
you have to bring the whole thing.
できたどの特性
So it's kind of the same
を
thing
つけよ
with
うか
these,
な
with this car object. Whenever you want to look at this car,
何を作ろうかな
you need to bring the entire car. So that's to first follow that reference to find where the car is, and then not only that, for each of the wheels, and for any other object you defined in there, for example, a name is stored as a string, but hey, that's also stored by reference. So now it has to follow that reference to each one of those things that is inside that card.
これなら簡単簡単。
So when that happens, that memory can be stored basically anywhere. So the reference to what you're looking for could be stored basically anywhere. So you're looking for, you know, the first tire of your car. Well, maybe that one's in main memory. You're killing me explaining memory references. Hey, it's important context. It's important context as to how ECS is different from OOD. It becomes very important. Give me a second. I'm actually going to fall asleep and die by oxygen deprivation. Well, if you do, that would be kind of bad, so don't do that. Again, this is important context. So yeah, so one tire could be in the cache, one tire might be in main memory,
これでいいよね。
one tire might be in the disk. You don't really know, and the system has to go and look for it. So say
調合するよ。
the system, you click on the car and you go into memory to look for the
つけよ
car.
うかな。
System says, okay, I found the car. For example, we'll say it was in the cache. You were lucky. Your car is in the cache.
何を作ろうかな。
So now it looks into the cache and it says, okay, here is the reference to the car. Or where's the rest of the car? Okay, so I see a tire. So it needs to bring all 4 tires. And it looks around for the tires. It's not in the cache. And to your dismay,
よーい
one of those tires is in main memory. So now you have to make the journey to main memory through your house into your luxurious backyard where you have a much larger memory than your cache. And you have to look for it there. But that's just for one tire. You went to main memory, you found 1 tire. You still have 3 more tires to find.
よーいしょ。
Which, again, who knows where those tires can be? They could be stored in main memory, they can be stored in the disk, you might have to backtrack and find it in the cache. When you're passing things by reference, it is very memory efficient in the sense that it puts it wherever it can, but it's very bad for trying to access it very fast. Because if we just imagine this one trip to finding all of the tires, just the tires, not even everything else, you have to go 10 milliseconds to the cache to find the car, then another 30 milliseconds into main memory to find 1 tire,
何を作ろうかな。
and then one of your tires is in the disk, so you have to follow another 100 milliseconds into the forest to find your other car.
ちょっと自信
And
ない。
then-
どれを使おう。
And then you have to come back, look for the next tire. Also, if you want functionality in that car, say if you want the car to spin around, or
ど
you
れ
want
を
the
使
car
おう。
to, move forward, that's something that's also stored in memory.
新しい効果ができそうだよ。
And again, you can't bring the car to the showroom without bringing the whole car.
どの特性を
So you're
つけようかな。
basically running around your entire memory, trying to find every last reference within this object. Needless to say that's very
何を作
slow,
ろうかな。
because again, the process of just finding 1 tire for us was already, 130 milliseconds, not even counting backtracking, for 1 tire. And when we're talking games with lots of stuff going on, you'll have, your vector 3, you'll have your, your quaternion for rotation, you'll have your name, you'll have, maybe you want to store the actual mesh of it inside of the object, or you want to store animations, or if it spits fire, you have to include that in the object, and that's also a reference. So the references basically start adding up very fast. Oh, I'm out of cabbage.
何を作ろう。
So, obviously, very slow. And, say you have hundreds of cars in your game. You're gonna have to do the same process for all of those cars if you want to render all of those cars and actually make them do something. So that's kind of where data-oriented design steps in and says, no. No objects. Or at least as few objects as we can physically get away with.
私に何か用かな。依頼の方は順
So
調に
obviously,
進んでいるか。
when we're imagining our car, we can easily imagine it as, you know, this entity with all of these things attached to it that, you know, basically make it the car. When we view things in terms of just raw data, it becomes a little bit more challenging.
どれを納品するんだ。
So, instead of this car object that has all of these attributes and all of this functionality, now we have what we call this car entity. This car entity that has components associated with it. So think of it instead as 3 bookshelves where every shelf, well, where the first shelf of every bookshelf is related to each other bookshelf, the second one as well, so on and so forth, effectively parallel arrays, rather than, you know, a single object, like rather than a box where all of these things are just stuffed inside of it, which it's very easy to carry a single box where, you know, everything is stuffed inside of it. But again, that's very slow. If you're just trying to move the box, well, now you're lifting effectively 3 bookcases instead of just, you know, a couple of books from each case. So I actually do have an image. I said I was going to prepare something. This is the extent of my preparation. Give me a second. As while I... let's see. Image file. Was it downloads? Music shortcut. Who the heck are you? Get out of here. Accidentally made a shortcut. Okay. Unload image must shine. Okay. Behold, my image. Does it? I hope it doesn't look as bad as quality on my side as it does on your side. Can you see? Can you see this? Just let me know if you can see this. It's the worst quality possible. Excellent.
ロロナ、ちょうどいいところに帰ってきたな。
Oh, I can't. Okay.
ほら、この間の旅行の土産だ。
Souvenirs. We always enjoy souvenirs. Alright. You wouldn't happen to know how to make this higher resolution, would you? I can see it, just not read it. That's probably good enough. Okay, so what you're seeing are a series of spheres. So the top row is your object-oriented kind of approach to making a sphere, and the bottom one is your data-oriented approach to the sphere. So again, it's kind of hard to see. So we have a whole, at the top row is a series of sphere objects, and all of these sphere objects. Hold on, I'm pulling up the image on my own side so I can actually see it easily, instead of having to stare at this little tiny OBS screen. No, it's too complicated. We haven't even gotten to the good part yet. So, we have a top row of spheres.
この子がリオちゃん。最近お友達になったの。
Oh, I forgot I did this.
で、こっちがクーちゃん。私の幼馴染なんだ。よろしく。よろしく。お願いします。それじゃあ行こうか。私地図見ながら歩くから、 二人はゆっくりお話ししててね。ジロジロ。
おいおい、あんまりジロジロ見るなよ。こっちとら見せ物じゃねえんだ。
Just realized Rorona is Ilia's VA? Is she really? Hold on, I actually need to look that up. Actually, you just send me the image of it.
それより初対面の人に失礼な口聞かないの。ロロナから人形が喋るとは聞いてたけど、まさか漫才までやるとは思わなかったわ。
Those of you who just came in, we are taking a quick cutscene break in our lecture of... oh, I just realized you guys can't see the cutscene. The poorly made image is in the way. It's fine. Again, we are discussing Unity's data-oriented technology stack and its difference from object-oriented design for game development purposes.
ごめんなさい。なんで謝んのよ。人形が喋るくらいでいちいち謝ってたら世の中渡っていけないわよ。ごめんなさい。だからいちいち謝らない。ごめんなさい。はいはい、リオネラ、その辺でね。まったく、これじゃまるで私がいじめてるみたいじゃないの。おどおどしてないで、もっとシャキッとしなさい、シャキッと。はい、私もクーデリアさんのことロロナちゃんから聞いてて。
I've seen the images. My goodness. She's Rorona. She's even Emil. That's a name I didn't expect to see on here. Yao. Voices several Toho characters. Dang, this person's stacked.
あら、そうなの？ふーん。で、ロロナはなんて言ってたのかしら？私のこと。いろいろ世話を焼いてくれる頼りになる友達だって。そう。まあ当然の評価よね。嬉しくもなんともないけど。
素直じゃなくて意地っ張りで怒りっぽいとも言ってたけどな。
なんですって？ロロナ、あんたね。なんで怒ってるの？怒るに決まってるでしょ。誰が意地っ張りで照れ屋なはにかみ屋さんですって。そんなこと言ったかな。痛い。ごめんなさい。
聞いてた通りの性格みてえだな。
そうね。でも悪い子じゃないみたい。楽しそう、二人とも。
Alright, now we can... Let me resize back up the image. Because the cutscene, well, much rather see the cutscene, honestly. Too much of an ironic voice. The voice is great, so I don't know what to tell you. Oh, it's not letting me go anywhere. Because it knows that I can't make the deadline otherwise. Alright, it's fine. Yes, the image! I was going to I've been trying to talk about this image. Yes, the top row are a series of... Oh, yeah, a series of spheres. And how we would represent them in an object-oriented space. So, in these cases we would have all of these spheres pointing to references to all these attributes that kind of go along with it. Things like color, things like I can't read some of these things. But say, for example, how fast the ball can roll, its diameter, you know, radius, which I guess you could just derive from the diameter, but
どうしよう
all of these little things that you would associate with the sphere. And then instead, you compare it to the bottom, which is our data-oriented approach, where we have basically our spheres. But instead of looking at the spheres themselves, we look at the components that are associated with the spheres in parallel. So you can kind of see how some of the arrows are going down. It's because there's an association between those two particular components, which, again, if you look at the data-oriented design version, there are no spheres. The word sphere is just non-existent. So that's kind of the first major point of how ECS works, in that the things that we create, like our cars, our soldiers, all these little things, they aren't objects anymore. They're basically nothing but integers. Let me just shrink this down. Yeah, so they're basically nothing but integers. An ID, basically an entity ID. And we associate this ID with components. So for example, if we had our car example, we would have, say, our entity, which would be, well, our car, and a component that we would associate with this car would be, you know, the color, right? But we wouldn't, the car wouldn't know that it has color. That sounds kind of interesting to say, honestly.
遅いなステルクさん
And well, we do that for basically everything. So it's vector 3, which is an object, so we need to get rid of it. So instead we replace the vector 3 with what's called a float 3. This one is effectively primitive, in a sense. The system treats it as if it is. And that would be a component existing in a separate array by which we make an association with our particular car with its relative entity ID. So again, all these parallel arrays where one of them is the entity we created, so our car, any number of cars, which all of them are represented by nothing more than an integer. They're all just integers. And we associate components from other arrays with these entities.
ひょっとして私来る日間違えちゃった
Hold on.
すまない遅くなっ
Cutscene
た
is playing. Any questions so far? We're actually getting into the meat and potatoes of how to actually start thinking of working in data-oriented design with Unity, the Unity's ECS system.
ああ来たよかった
申し訳ない王国祭の準備でいろいろ手間取っていてな
Parallel dimensions? Exactly. All of these dimensions are interacting with each other in parallel. Do I need to have linear algebra as a prereq? No, because Unity does all of the work for you in that regard. You don't really need to, you never actually see the arrays. Wait, oh, sorry, you're taking linear algebra right now. You're literally working on it. It's a co-requisite for you.
まったくなぜ私が
So
街の飾り付けにまで呼び出されねば
that brings us to our first two parts of the ECS. Entities and components. Again, entity is nothing more than just an identifier to, you know, differentiate between all 100 of our cars. And what we'll take is something called a component that we will basically associates with this, with each of these entities. So for example, 4 tires we will associate with this car. The car doesn't know it has tires. The car doesn't really need to know that it has tires. The tires don't know that they're associated with a car. None of that is really important to them. So it's like how we mentioned the showroom example. If somebody walks in to your dealership and is like, I want to see a car. You're like, great, you want to see a car. Alright, here's a photo of the car. And they look at the photo of the car. You have saved yourself from having to drag the whole rest of the car into the showroom. And they're like, I wonder what the tires of this car look like. And you'll be like, okay, you want to see the tires of the car? You bring out 1 tire for them. Here's what the tire of the car looks like. You don't need to see the rest of the car. It's right there on the paper that you just gave me. So instead of accessing the entire car and everything associated with it, all of its attributes, all of its functionality, you're only accessing what you need, the bare minimum of what you need. So if you don't need all 4 wheels, don't look for all 4 wheels. Only search memory for the first wheel. If they want to sit in the car, let them sit in the car. The car doesn't need an engine though. The car's not going anywhere. Just let them sit in the car. Which, if you really want it to be cynical, you can say you also technically don't need wheels to sit in the car. But and then you have to wait until they're actually like, okay, I feel like driving this car, when you decide, okay, fine, I'll bring you the whole car. So that's kind of how we think of these entities and these components. Only access what you want. So you're not accessing memory a million times just to get one of the things you need. It's like, I lost my train of thought.
君には関係ないことだったら忘れてくれ。時間がないので早速だが今回の評価を伝える。
Okay, I need to get my evaluation for this. 3 stars. I already knew I got 3 stars, but it's fine.
どうやら無事依頼をこなしてくれたようだな。安心した。
Oh, but that's what I was trying to say. I went through the trouble of explaining the memory hierarchy because it is very important for this exact step. Only accessing what you need. And also the idea of these parallel arrays. I didn't mention it before, but whenever you grab something from main memory or disk, you actually bring it up into the cache. So, you find the box that you buried in the forest, and you're like, okay, let me bring this box, and we'll just say the other 5 boxes that just happen to be stored next to it. Let me bring all those into the house. And when you're looking for, say, your tires, you have 4 of them, you look for 1 tire in main memory or your disk, and you bring it back to the back up to the cache. So it's like, great, I have 1 tire. Oh, but I also need the other 3 tires. Oh, whoa, let's look at that right there. Right next to the tire I just grabbed is the 2nd tire. And right next to that one, oh well, it's the 3rd tire. And when you look at that, the next one, right next to it, is the 4th tire. So we are trying to use the principle of locality. Similar things that you're going to need at the same time are placed close together. So by using this system where we're not referring to everything as individual references that jump you to all these different places around your memory, you minimize cache misses, having to leave the cache, by using this principle of locality to access things significantly faster. Because in this example, say your tires were in main memory and you had to go to main memory to get it, 40 milliseconds, so to speak, and you need to find the other 3 tires. Well, you're already in the cache and all of them are already there as well. So you basically just saved yourself, you know, an extra trip to the disk or main memory or the disk again to find these other things. So that's kind of one of the major points of ECS is minimizing cache misses to increase performance. Because again, it is, even in just this example, which is probably even more so in larger systems where, you know, accessing the disk was 10 times slower than just accessing the cache. So, let me finish this
城の
dialogue.
者たちも君と同じくらい働いてくれればこんなに苦労せず済むものを。それだけならまだしも今年は大間でどいつもこいつも。
ステルクさん。
すまない。どうも平常心を失っているようだな。よし、もう大丈夫だ。では次の依頼の内容を伝える。
Next assignment, make a tonic. That's it? Just a tonic? That seems kind of too easy. Oh well.
土地を肥沃にするための。
ああ、すまないが時間がないので詳しい説明は省かせてもらう。ああ、それと王国祭の間くらいは君も仕事を忘れて楽しんでほしい。そのために私が今苦労しているのだからな。
はい、ありがとうございます。
Dang. There's more stuff. Usually completing the assignments are fairly fast because they just show you the assignment, give you the next assignment, and then you're just off doing your own thing. But I guess there is a whole festival that's going on right now, technically.
わあ、すごい人。そっか、もうお祭り始まってるんだ。どうしよう、ちょっと見ていこうかな。よし、見ていこっと。せっかく1年に一度のお祭りだ
I
もん
mean, I
ね。
know I'm lecturing right now, but it'd be such a shame to miss this, whatever the heck this is.
ロロナちゃん、こっちよこっち。
あ、エスティさん。エスティさんもお祭りの見学ですか？
You're gonna go to sleep, watch the VOD for this, the lecture? Actually, alright, I will make sure to go into excruciating detail. Milk those watch hours. And you'll have to go all the way to the end for the, you know, the most important details. So prepare yourself.
私はお仕事よ。ロロナちゃんは楽しんでる？楽しんでるわよね。
But I guess at the very least you can skip to the end of this cutscene, since I guess I won't start until the end of this cutscene.
もうほんと羨ましいよね、まったく。
ごめんなさい。よくわからないけど、ごめんなさい。
冗談よ。ちょっと八つ当たりしただけ。そうだ、ここで私に捕まったのも何かの縁だし、ロロナちゃんも参加していきなさいよ。
参加？何かイベントでもやってるんですか？
そうよ、今年のメインイベント、その名もキャベツ祭り。
は？キャベツ祭り？
というわけで、はい、1名様ご案内。
出るって言ってない。待ってくださ
い。皆さん揃ってますね。それではこれよりキャベツ祭りのルールを説明します。
結局参加することになっちゃった。
ほらそこ、ちゃんと聞いてないと分かんなくなっちゃうわよ。
Oh gosh, there are even rules. Oh gosh, okay. Time has 2 minutes, the other one captures everyone else to win. Her basket might not be completely empty at the start.
わかりましたね。質
Of
問
course
その
not.
他もろもろは一切受け付けません。では時間も
I
押
guess
してる
time
の
to
で、
get our YouTube
王国
mandated
祭メインイベン
gameplay
ト
in, I
キャベツ
suppose.
祭りスタート。
Titles are designed to be misleading, but... we do play the game here. Question is, where are they even dropping us for this?
頭がフラフラする。もうみんな行っちゃった。私も早く始めないと。
Oh gosh, I'm timed. Okay. So yeah, so when we were considering ECS, we've so far only discussed the E and the C, which we'll save the S for a little bit after a little bit more context. Because obviously the goal of ECS is to get rid of as many of the objects as possible to, you know, increase performance. But unfortunately, it is impossible to remove all objects. We are still coupled to a number of objects, specifically the ones that have to actually physically exist in your 3D world. So when you put things into your world, you do still instantiate them in a sense, but they undergo a process called baking. So basically, you would create a script called that inherits from Baker, which inherits from mono behavior, and the Baker will basically go through the process of converting the game object in the scene into an entity in the subscene, which, you know, subscene functionality is a bit complicated, so it's not going to be a real concern right now. I basically know that there's going to be a subscene within your main scene that actually holds all of your entities. So at each of these, so every time an object is instantiated that has a Baker, it gets immediately converted into an entity for entity purposes, you know, actually doing anything that involves entities. In addition to that, the Baker is where you're able to add components to your newly created entity. So for example, if you have a component called HP, which stores some integer value, during the baking process, if you were building your car, you would decide that, okay, I'm going to give this car HP. So in the baking process, you would add components, this HP component that you just created, to your entity, the newly created entity. Hold on. What the heck is all this stuff? So now you have this entity converted from a game object that now has the components you want it to have. Now I will note that there's a limit to what can be in a component. And basically, any kind of reference variable is not allowed as part of a component. So for example, you can't really put a string into a component. You also can't put, we mentioned before, vector 3s, because those are also objects. You're not allowed to store those in components either. Any user-defined functions, not functions, classes, not permitted to put inside of components. So you're basically stuck working with what Unity gives you that is compatible with components, or you're stuck with primitives, which in a lot of cases isn't like a terribly big deal, but it does mean that you are going to be a little bit limited in how you actually organize the components of the game. But again, this is data-oriented, so we're focused on having as few objects as possible to begin with. So you have baked your game object into what is now an entity, and this entity now has the components associated with it, again, not objects. So they're not attributes inside of this object. They are components associated with a particular entity ID. So from this point, you need to actually do something with all these components that you've just gone out of your way to make. Which your entity can have. I will say, I don't. It's obviously it's not like an infinite number of components, but you shouldn't ever really be in in a situation where you'll hit the cap for components. So usually it's not going to be a concern. But yeah, so now we need to actually start performing functionality with these entities that we went out of our way to create, which again is an annoying process because you have to go through the process of baking it. Then you need to know what actually to do with them, and that's where systems come in. Systems are basically the functionality. Like, functionality does not exist outside of the systems, with the exception of the objects that you are just required to run. Things like UI, animations, and all that stuff. Unfortunately, you have to still do those using mono behaviors, but for a majority of everything else, it can be represented as entities with components.
いきなりでバタバタしちゃったけど、結構面白かったかも。ロロナ、やっと見つけた。
Okay, this cutscene is playing.
あ、クーちゃん。どこにいたのよ。ずっと探してたのに。もしかしてあのイベント参加してたの？してたっていうか、させられてたっていうか。よくやるわね。あんなくだらないこと。で、どうだったのよ。それはこれから。
お待たせしました。いよいよ優勝者の発表です。
あ、始まるみたい。
栄えある第1回キャベツ祭りの優勝者は美少女錬金術師のロロナちゃんです。はい、みんな拍手。
Woo! Definitely wasn't rigged. Definitely wasn't just
私
replaying the game like
美少女って
normal.
何？すごいじゃないロロナ。普段はどんくさいくせにやるときはやるのね。何かの間違いじゃないかな。私が優勝なんて絶対おかしいって。うだうだ言ってないでとっとと言ってきなさい。押さないで。
おう、やっと出てきたわね。
Please tell me I actually get something for this.
ごめんなさい。私なんかが優勝しちゃって。
なんで謝るの？ほら、ちゃんとして胸を張って。はい。よろしい。さて、ロロナちゃんには優勝商品としてメルクリウスの瞳が贈られます。
I had to fill up my entire inventory just to get this thing, and now I have to chop away a cabbage. That's fine. Oh, dang, it's an equipment.
さらに副賞として、なんと名誉あるキャベツ娘の称号が授与されます。おめでとう。
I don't know if I'd call that a reward.
ありがとう。キャベツ娘？
はい、皆さん、キャベツ娘に今一度盛大な拍手を。
Woo!
いいぞキャベツ娘。
キャベツ娘かわいい。
よキャベツ娘世界一。
キャベツ娘結婚してくれ。
Woo!
そんな、やめて。こんな称号いらない。
My goodness.
恥ずかしかった。確かに恥ずかしいわね。よっ、キャベツ娘。やめてよ、クーちゃんまで。もうこれくらいでいじけないの。 線がちょっと痛いけど。みんなすぐ飽きるわよ。ほら早く早く。待って。
Alright. Back to talking about systems. I think I'm being able to talk about systems. Capture system.
なんだかんだでもう1年経っちゃったのか。
Oh dang, it's already been a year. Somebody told me to actually make this last an entire 3 years that this game takes place in, but what, I'm like 2 months? If even that. In terms of actual real-time commitment.
最初に師匠にアトリエを任されたっていうか、丸投げされた時にはどうなるかと思ったけど、ダメダメ、終わった気になるのは早いって。まだ2年も残ってるんだから。よし、気合を入れ直して次の依頼を始めよう。頑張るぞ。
Oh yeah, she's here.
そうか、もう1年経つのか。早いものだな。もしこのまま最後までやり遂げるようなら、その時は、いや、先のことはその時考えるとするか。もうしばらく弟子の成長を見守る師匠の気分を味わうのも悪くはないしな。
Okay, now can I talk about systems? Please note that the party members have been removed since the annual festival. Wait. I need those party members back.
おい、そこの騎士。
Okay, so I can't
こ
talk
れ
about
は
systems.
どういうおい、この私が呼んでいるんだ。私の名はステルケンブルクです。いい加減覚えていただけると嬉しいのですが。貴様の名前など知ったことか。どういうことかと聞いているんだ。いきなりどういうことかと問われても答えようがありません。何についてのご質問ですか。しらじらしいこと。アトリエのことに決まっているだろう。なぜあんなアトリエ一つ潰すのに1年以上もかかっているのだ。発言にはお気をつけください。我々はアトリエを潰すためではなく、力量を図るために依頼を出しているのです。建前はどうでもいい。この1年で私の開発計画がどれだけ狂ったか。私の計画が狂った分だけ国の利益も損なわれているんだぞ。損なわれた利益はあのアトリエがもたらしてくれているでしょう。どうだかな。貴様のようにあのアトリエに肩入れしていればそういう風に見えるのかもしれんが、私は一人の騎士として常に王の意向に沿うよう動いております。恥じるべき点は一つもありません。よかろう。ならばこちらにも考えが。何をなさるつもりかは存じませんが、ことと場合によっては黙って見ているわけにはいかなくなりますよ。生意気な口を聞くな。何を企んでいるのやら。あいつがアトリエにいる以上余計な心配はいらないだろうが、いや逆に騒ぎが大きくなる可能性が高いな。面倒なことにならなければいいが。
Okay, now can I talk about systems? Yay, we can talk about systems now. That only took a very long time. Though it did help because I did happen to need a whole lot of cabbage.
今日はもうどれくらい
Systems!
休もう。
Yes, systems. There are two main kinds of systems that are designed to basically manipulate the data, so to speak. Guess before I go into the types, when you're working with a system, your goal is obviously to operate on some number of entities. So the way you would find which one you're looking for, because normally Say for example, if you were just working in objects, you would just, have an array with all those objects stored. Or for example, if somebody clicks on it, you would have an on-click event that operates on this object that you can basically do whatever the heck you want with it, or tell it to do whatever the heck you want it to do based on the methods you've created for it. So for example, if you press on the gas pedal, the car will drive. In an object-oriented approach, you would call a method within the car that will basically drive the car. It'll do everything it needs on its end, manipulating the vector 3, doing physics calculations, all that stuff. With systems, in data-oriented approach, you don't have that car on hand because, again, it technically doesn't exist. It's just an integer. So what instead you do is you do what is called a query. So you would basically search all of the entities that exist within the system, your system, in the game, and you would say, okay, hand me all of the entities that have the component HP, for example. Say some explosion happens and you need to operate on everything all at once. You would just say, hand me every single entity that has HP. And as you start adding more and more components to each of your entities, you can get even more and more specific. So for example, you could attach a component to your car that says, hey, this is a car. So we call those tags. Though they're also components, and they basically just serve to allow you to query for them easier. So you say, okay, I want to query all entities that have the car tag, and that'll get you access to all of the cars within your game. Say you want to be even more specific. For example, something explodes and it has an explosion radius, and you only want to subtract HP from the cars that were caught in the blast. So it'll perform its physics calculation to figure out which ones were hit. Which, that's the physics system, we don't worry about that. But once you know which ones, the actual, again, because inside the game, they're still technically objects. So it'll find these objects, and the entity in the subscene that is inextricably linked to this object, and it'll say, okay, I found this entity right now, but I want to be able to query for it. So when the explosion occurs, everything that gets caught in the explosion, all the entities, you'll say, okay, let me give these cars this other component that says is exploded or has taken damage, for example. So we'll call this for now the taken damage tag. Again, it's another tag. It doesn't have any data associated with it, but it's a component that we attach to this entity that we say will help us query it later. So we have a system that performed this physics calculation and said, okay, for all of these entities within this space, I'm going to attach onto it this is damaged component. So now that you have that component, you can, in a different system, for example, we'll call it the calculate HP system. Within the system, we'll be like, okay, let us query for every entity in existence that has this is damaged tag. And this is damaged, and it will find all of the cars that were caught in this explosion, and it will decrease HP by some set amount. If you want to extend it even further and make different kinds of explosions, or say for example, deal more damage depending on where you were relative to the explosion, you could instead say, okay, explosion occurs, I give it this is damage tag, and again, which is a component, and we can instead make it a component with data. So we can apply to it an integer value saying, here's how much damage this thing took. Again, another system calculated this and applied this new component to all of the entities caught in the explosion. So now our system, our calculate HP system, will subtract the desired amount
なんだろう
of
結局
HP from the cars
向こうの方から
caught in the explosion. So think of the system we just created, the calculate HP system. It doesn't specify that the damage had to come from an explosion. All it was looking for is that the entities have the is damaged tag. So with this system that is very generic, we can use it for basically every instance of damage across our entire game. You're caught in an explosion, put an is damage tag on it with some arbitrary number of hit points to be reduced. You get into a car crash, you can put has damaged on those cars with a different number of hit points to be lost. Say your car gets shot. Just put on it is damage tag onto the car, and for all of these different instances, which are all entirely unrelated, the system will be able to operate on the data that is the HP of a car for any of your cars. Because again, all of these cars, they don't exist. They're just integers representing an index where our data is associated with. So again, that creates a lot of flexibility for us after this cutscene.
あの人が弾いてるのかな綺麗な音
ん？お客さんがいなくなっちゃったな。
ごめんなさい邪魔するつもりじゃなかったんですけど
お、これは気にしなくていいよ。僕の音楽は動物たちのためにあるんじゃない。君のように愛らしく可憐な少女に聴かせるためにあるんだから。
はあ愛らしい私ですか
もちろんだよ。君は気づいてないのかい？自分自身の魅力に。
私なんて全然チンチクリンで
ああ、うつむかないで。もっと君の顔を眺めていたいんだ。面白い反応をする子だな。
私仕事の途中なんで失礼します。
あ、待って。聞きたいことがあるんだ。女の子がこんな場所にいるってことは、もうアーランドの街は近いのかな？
向こうの方に歩いてけばそのうち。
そっか、ありがとう。小さい頃に住んでたんだけど、久しぶりだからすっかり道を忘れちゃったね。君はアーランドに住んでいるのかな？
はい、私町で錬金術のアトリエやってるんです。それで
また会えるといいね。運命的な再会を期待してるよ。愛らしいお嬢さん。
また愛らしいって恥ずかしかった変な人だったなじ ちょっとだけ嬉しかったりして。と、いけない。私も仕事に戻らないと。
My goodness. What was I trying to do? Oh, that's what I was trying to do here. Systems. Yes, systems. Let you operate on your data. All on the basis of querying for entities that have particular components. So, for example, if you have if in your game you have all these cars, oh crap, I forgot that my party wasn't configured. I'm probably dead here. But yeah, in all of these cases where you want to show everybody what the HP of all the cars are. You know how whenever you have a game with a lot of guys that all have HP, it normally shows above their head. So, say we wanted to implement that, we could have a system that queries for every single entity that has HP, and then, do, well, what you normally do, just have a conditional. If the HP is, not full, then you display how much HP they have. And again, it doesn't matter what kind of entity it is. It can be a car, it can be a person, it can be a building. As long as it has an HP, the system can query for it, unless you choose to be more specific. So that's kind of the power of systems that we're looking at here. Things that can be reused over and over again because they're no longer associated with a particular object as one of its methods. For example, prior, if you wanted to have a method of dealing damage to a particular car, you would invoke a method in the car that says, here, reduce your damage by this amount. But in order to do that, you would have to, get a hold of a reference to the car, which, as we explained earlier, is a process that involves you, hopping through memory, through all these references to find where exactly your car is. Because again, you can't show up without the entire car. But here you can. With our car, if we only want the HP, we only need the HP. If we only want to, to see the car's name, we only need the car's name. Everything else is optional. It's a similar situation when you're querying. You can say if you only want cars that say you have different types of cars that have varying numbers of wheels, and just for some reason you decided, okay, I'm going to differentiate between these cars with different tags. So for example, we have a 4-wheeled car, we have an 8-wheeled car, or we have a 16-wheeled car. I don't know what an 8-wheeled car looks like, but just bear with me. And each of these things are separate tags to make querying for them faster. So in our isDamaged system, we were very generic. We only wanted things that had the tag and that have HP. So we'll make a new system, for example, that says, I don't know, drive 18-wheeler. So this system only cares about 18-wheelers, which again is just a car entity that we created that has the component of 18 wheels associated with it. So we can query, say we want to drive this 18-wheeler, we would query for all entities that have this tag 18-wheeler, and say for example we're trying to drive this 18-wheeler, so this 18-wheeler will have components associated with, well, it's driving. Like if you ever played like Mario Kart, you have like your speed, acceleration, handling, weight, all these things that are associated with the cars themselves. So say we want to drive the car, we can query for all entities that have the 18-wheeler tag and have these stats. I'll say these stats are all their own component. So there's one component for speed, acceleration, handling, and weight. I forgot what the fifth one is. And if you want to operate on all of those, or not, even if you don't want to operate on all of them, you just want to know them, you can query. You can include these components in your query, and you'll basically have a local instance of those, a local copy of all of those different components that you can use to do math, or if you query them as read-write, you can actually edit them, or you can query them as read-only, which is going to be faster. So for things that you don't need to edit, you should query as read-only. And you can basically do whatever the heck you want with it now. So not only do we have the tags that let us query for things easier, within a query, we can receive local copies of other components that this entity has. So we would say query for all entities with or has tag 18 wheels, and we would also query for speed, acceleration, weight, handling. So it'll only pick up entities that have all of these components, meaning you can ignore basically everything else. So I know I always say query your entire game for all these entities, but by using tags and components, specific components, you can basically filter out a majority of them pretty quickly.
そういえばあの人はちゃんと町につけたのかな。
I'm going to get through this dialogue right quick and rebuild my party.
やあ、久しぶり。
やっと帰ってきたか、この宝刀息子が。
なんだ、まだ元気そうじゃない。わざわざ呼びつけるからくたばる寸前なのかと期待してたんだけど。
お前こそよくものたれ死なずにいたものだな。ろくに連絡もよくさず10年近くもフラフラしよって。
はいはい、そこまで。説教するために呼び戻したわけじゃないんでしょ。
そうだったな。一つお前に仕事を手伝わせてやろうと思ってな。
仕事ね。少しだけ期待してたんだけどな。
何か言ったか。
別に。で、仕事って何さ。言っとくけど、つまらないお役所仕事なんてお断りだよ。
その程度ならわざわざお前に頼まん。この町に顔見知りのいないお前にうってつけの仕事だ。あの目障りなアトリエを潰すためのな。
アトリエ？一応聞くだけ聞いてみようかな。
Whoa.
おい、ロロナ。お前、カタコンベに行った
Oh
こと
yay,
あ
new
る
area.
か？
カタコンベ？
名前も知らんのか？ほら、町の近くにある墓場みたいな遺跡のことだ。
ああ、あそこカタコンベって言うんだ。まだ行ったことないです。なんだか不気味だし。
そのカタコンベだがな。あそこではいろいろ珍しい材料が取れるんだ。特に錬金術師にとっては重要な霊的な力を持つ材料なんかもな。
へえ、じゃあ行ってみようかな。ちょっと怖いけど。
その代わり幽霊が出るともっぱらの評判だがな。
はい、幽霊？
ああ、噂によるとかなり凶悪なやつらしい。 これまで迂闊に足を踏み入れた人間が何人も食い殺されたりしたとか。
やめてくださいよ。私がそういう話ダメなの知ってるじゃないですか。
おや、そうだったか。いや、こいつはうっかりしてたな。
めちゃくちゃ棒読みじゃないですか。もう絶対そんなとこ行かないですからね。
あそこで取れる材料は必要ないというのか。もったいない話だな。
それは
まあ、行くか行かないかはお前の自由だ。もし行ったとして命の保証は。
だからそういうこと言わないでくださいよ。もう師匠の意地悪。
Yay, new area. Alright, systems. So many things have been getting in my way of describing systems. Yeah, so summarize all of the basic components of components. I've said that word way too many times now. ECS, Entities Component System. Entities are representations of, you know, actual things within our game. The components are the data associated with those entities. And then the system is how we actually manipulate these components. Again, so components are applied to objects during the baking process, which converts them to entities. And again, basically every object in your game, if you're running a fully ECS system, is going to be baked to some capacity. And then, aside from that, you have the systems, which allow you to query for entities with particular components, allowing you to act on only the things you need and only access the data you need. So for example, if you only need to see the color of your car, only look for the components related to the color. You don't need everything else in the car. And then, yeah, so querying with systems to manipulate your components, which you can either change the data on your on those components related to an entity, or you can even just add or remove components. For example, in our is damaged example,
どうしようかな。一緒に来てもらおうかな。
we apply the is damaged tag to vehicles or just anything really that we want to deal damage to.
私で
So the system will then go and look at all these things, and it will do its math. It'll calculate, it'll update, it'll handle all of that stuff. And then, however, if you don't remove the tag, then after a couple of frames, it's just going to be like, oh wait, there's this thing that I need to remove HP from. So that's why in the system, the update, or sorry, calculate HP system that we designed, which removes HP of things that are damaged. In that system, after we do the math we need, or before, it doesn't really matter,
あら、ロロナ。
we
どう
need
したの？
to remove
ど
the
うしようかな。
component that differentiates damaged entities from entities that we no longer need to do HP
一
calculations
緒に
for.
来てもらおう。しょうがないわね。
So a lot of actually getting anything done in the ECS in relation to your game is manipulating components. Manipulating the data on the components, manipulating what components your entity has and doesn't have, and, you know, basically operating on those components. So, there are two types of systems. I mentioned before how the goal of ECS is to remove as many objects as possible. Well, I also mentioned how that's not possible. There are still some that you have to deal with. So there are two types of systems that handle those two situations separately. One of which is the system base. System base says, you have things that are passed by reference? Fine, you can still have those. It will allow those. And so you're allowed to have things like strings and vector 3s and game objects and all these, and cameras and all these things that you aren't able to store in components. These are systems that will allow you to use those. On the other side, you have the eye system. The eye system is designed just pure ECS. You're only allowed to use basically things that are supported by components, as components. You're not allowed to use, objects basically inside of them. However, they run really fast. Much faster compared to system base. And the main benefit is that you're allowed to use the burst compiler, which we've only done like a very bare minimum discussion of what the burst compiler is. But basically, when it's compiling your code, it converts it to native code, which is much closer to machine code and very easy, not easy, very fast for the system to work with. So with that, I forgot what I was going to say. So yeah, so eye system, you can use the burst compiler to get insane performance boosts. Like, I mean, actually, like, kind of crazy. I remember seeing some comparison test related to burst versus without burst, but just know it does increase performance a lot a bit. You're only able to really use burst compiler on eye systems or on jobs, which that's a whole separate thing. We don't talk about jobs in this particular lecture. Or on system bases that don't have anything that burst doesn't support. Which, easiest way to figure out if burst supports it or not, literally put burst compile above whatever the system you're trying to use, and if it throws you an error during runtime, then it probably isn't going to work. Uh-oh.
やあ、また会えたね。愛らしい子猫ちゃん。
いきなりミミカ、私猫じゃないです。人間です。
そんなにはしゃぐくらい気持ちよかった？それじゃ反対側の耳を。
何しに来たんですか？
ゆうべ夢の中に君が出てきてね。そして君に呼びかけようとして気づいたんだ。君の名前すら知らないことに。わかるかい？振り向いてほしいだけなのにそれすら叶わないこの胸の苦しみ。
いちいち恥ずかしい言い方しないでください。ロロナです。私はロロナ。
ロロナか。詩的な名前だね。たった3文字なのにこんなにも心に響く。
だからそういうそういえば私も名前聞いてなかったです。
僕かい？僕は都立。いや、一応隠した方がいいかな。タントリスってことにしても。僕はタントリス。しがない旅の吟遊詩人さ。
タントリスさん、タントさん、トリスさん、どっちも言いにくいかな。
でも君の方から名前を聞いてくれるなんて、これは期待してもいいのかな。
期待って何を？私はただ呼ぶときに困るから。
慌てた顔も可愛いな。つい意地悪をしたくなってしまう。
さっきから黙って聞いていれば。貴様、誰の の許可を得て私の弟子と甘い雰囲気を作っている。
師
おや、これは大変失礼を。このアトリエには愛らしい少女だけでなく、あなたのような霊人までいらしたとは。
歯の浮くようなことを。あ、貴様どこかで。
そうそう、要件を伝えないと。ロロナ、君が国からの理不尽な命令で苦しんでいると聞いてね。微力ながら力になれないかと思う。
匠ですか？
頼りない僕だけど、君を守る盾くらいにはなれるから。困った時は遠慮なく声をかけてほしい。ということで、それじゃ。
逃げたか。
なんか師匠の顔見て逃げたみたいでしたけど。
まあいい。問い詰める機会はこれからいくらでもあるだろうからね。
師匠？言っちゃった。はあ、もういいや。
Damn, this guy's probably expensive. Oh, the game's laggy. Oh no. Oh, look at how slow those stars are propaganda. Okay. Oh, look at this lag. Although that's probably a good sign. We have gotten about to the general end of the lecture. We've briefly discussed why ECS and what ECS. Again, it's just a single component of Unity dots, but as far as like general development is concerned, the entity component system architecture is kind of the basis of everything. Thinking of things in terms of data rather than as objects. You have your entities, which are basically just integer identifiers that represent the actual things in your world. Your game objects, which are the things that exist in your world, are baked into entities where you can apply components to them and provide them values. Components can include primitives or data types supported by components, so one specifically made for that purpose. Components can also simply just be a tag, no data associated with it, but something that allows you to query for it easier within a system, be it an I system, which is only for data types supported by components, or the system base, which allows basically anything to happen. I system being the faster of the two and the one that I think is the most supported. So yeah, so that's kind of the very basics. Obviously I didn't go into syntax because I'm not going to literally recite code. That would not be fun for anybody. But yeah, if there's demand for it, maybe I'll do another lecture on it. There's not really a whole much more I can explain without going into syntax. But if you are interested in the syntactical side of things, there are a couple of channels that are kind of the go-to for this. Turbo Makes Games is the Dots guy. He's touched most of the features that Unity Dots has to offer, and he has in-depth tutorials on working with the ECS system. And then there's also the Code Monkey, a classic, who also has ECS tutorials. He even took a full working game made with the general approach and converted it into a game that runs with ECS. So those are two resources that I would recommend most. Not me, the random person that has spent several months on Unity Dots, rather than the guys who have spent the years before even the pre-release on it. But yeah, for now. I don't know when that I'll have to do this Atelier stream again. Terraria is on Sunday as usual, but this one in particular I'm very busy. So I'll see if I can get another lecture out. If I do get another lecture out next week, it'll probably just be back to object-oriented design and agile, like the agile process and all that stuff. But the more useful stuff for everybody outside of the namespace. But yeah, but for now, I will be around.